This lesson we're looking at another technique to find the derivative called the chain rule. Now I'm just going to start with a simple equation. So let's say 2x plus 3 all squared. And in previous chapters, what we would have done is expand the brackets out before deriving. So we've gone 2x all squared would be 4x squared plus 2 lots of 2x times 3, so that'd be plus 12x plus 9. And then we found the derivative of each term in this equation. So 4x squared would become 8x, 12x would become just plus 12, and the 9 would drop off. So that's how we'd find the derivative. Now, that works when we've got a squared bracket. Let's look at another technique that you could use that will help us when we have a higher power than 2. So, for the chain rule, we put what's inside the bracket, what's been raised by the power, so in this case it's 2x plus 3, we set that equal to a new variable called u. So if I let u equal 2x plus 3, then this original equation would become y equals u squared. And the derivative, dy du, would be equal to 2u. Now, I wanted dy dx. So I look at what I've got, u equals 2x plus 3. Let's also find du. So now I'm differentiating this equation u in terms of x, or with respect to x. So now the derivative of 2x plus 3 would just be 2. And if I multiply these two answers, dy times du times du dx, I'm going to find that my du's will cancel off, and I'll end up with dy dx. So, let's look at our dy du was 2u times 2 over here. So that means dy dx equals 2u times 2, which is 4u. And I know from the beginning that u was 2x plus 3. So this becomes 4u, and u was 2x plus 3, which equals 8x plus 12. Now, I can hear you saying to me, why would I do that, Mr. Mead? The first way was a lot quicker. I got the same answer, yep, but look at all that working out. I used 3 different color pens. I've only got a blue pen, Mr. Mead, and I want to do it my way. What happens when you see a question that looks like this? Y equals x to the power 5 minus x to the power 10 all to the power of 20. Or one that looks like this. Y equals the square root of 1 plus x squared. Are you going to expand these brackets first by hand? Didn't think so. So, let's use our chain rule. So, first step, let u equal what's inside the bracket. Then, find du dx. So that would be 5x4 minus 10x9. And then, you can write y in terms of u. So have u20, so dy du equals 20 u19. Now if you wanted to, you could put all of that u stuff back in there, but the derivative, we're going to multiply these two together. So therefore, dy dx is going to equal 5x4 minus 10x9 multiplied by 20. And what was u? U was x5 minus x10 all to the power of 19. So your final answer would be 25x4 minus 10x9 x5 minus x to the power of 10 to the power of 19. Okay? So, recapping those steps, if you've got a power that's much bigger than 2, even if it was a cubic and you're feeling particularly lazy on that day and you didn't want to do it by hand, just let the entire bracket equal u, find du dx, then write y in terms of u, so it's just whatever the bracket to the power of 20 in this case. So the derivative dy du, and then multiply your two answers. So you're getting dy du, dy, oh, it's too chunky, du dx times dy du equals your dy dx. Okay, notice how I've got no u's in my answer because I didn't start with a u. I've just made up a new variable, so make sure you sub all your u's back in. The great news for that is it also works with fractionals and negative powers. So let's look at this one over here. So this can be example 2. We've got y equals root 1 plus x squared. So I can write that as 1 plus x squared to the power of a half. So therefore I'm going to let u equal 1 plus x squared. So du dx would equal 2x, and y equals u to the half. So dy du is going to equal a half u to the negative a half, which is the same. Let's put u back in if you wanted to. A half 1 plus x squared to the negative a half. And then, therefore, dy dx is going to equal these two things multiplied by each other. So 2x times a half 1 plus x squared to the negative a half. And we should tidy this up as well, shouldn't we? So 2 times a half, obviously dropping off, becomes 1. So I have x times 1 plus x squared to the negative half, which is the same as the square root of 1 plus x squared in the denominator, because that's a negative half that goes down to the denominator. So that's my dy dx. Okay. Have got the set questions from 20A and B, but the main thing is we're setting u as the whole bracket and then deriving that in terms of x, and then deriving y with respect to u, and then multiplying the answers to get the derivative of y with respect to x. You might also see it written in function notation, and it'll look a little bit different. You'll have, so this is your chain rule formula. You'll have what we've just covered then, dy dx is equal to dy du times du dx. And for function notations, we can just introduce a new term, or new, if we've got a function f, we can say it's a function of g with the derivative of the function of f in terms of g with respect to x would equal the derivative of f of g of x multiplied by the derivative of just the g of x. So that's just saying make a new function with inside, like we made u inside the bracket, and then derive that, just treating that as a whole constant, and then multiply by the derivative of that inside the bracket part. Okay, so two different ways of writing the same technique. Whichever one you feel more comfortable with, I'd recommend using. All right, all the best.